Okay, ladies and gentlemen of algebra, this is Unit 8, Notes 2. We're talking about adding and subtracting radical expressions. So here's what you need to be able to do. You need to be able to add and subtract radical expressions. So what's that going to look like? First off, let's start with this, simplifying the expressions. So if I look at the first one, remember how we do this, we break it up into what is a perfect square root. Now when I say perfect square root, I'm talking about 4, 16, 64, 81, things like that. So when I look at 40, I got to start automatically seeing, hey, I can break that up into 4 and 10. So I chose 4 because 4 is a perfect square root. So square root of 4 is going to be 2. Square root of 10 is square root of 10. That is simplified. Most kids, a lot of kids will split this up into square root of 8 and square root of 5. That's fine. You can still get to that answer, but you've got to realize that you can break up 8 into 4 and 2 and still have square root of 5. So you still have that square root of 4 and get 2. Then put these two together underneath one square root, and you're going to end up at the same spot. Like 24x to the fifth is going to be that same kind of idea, except I'm going to take this in two parts. I'm going to go square root of 24, square root of x fifth. Square root of 24 breaks up into square root of 4, square root of 6. Once again, I chose 4. So that's going to be 2 square root of 6. Now, x to the fifth and x is going to be split up into a couple things, actually. I'm going to do it this way. Square root of x squared, square root of x squared, square root of x. X to the fifth is x squared times x. I just split it up into each little own square root. So square root of x squared is just x, square root of x squared is just x, square root of x is square root of x. So this essentially becomes x squared. So when I put this together, I get 2x squared times the square root of 6x. There would be my simplified answer right there. Okay, now, how do I do it when I try and add, subtract? Add, subtract, it's a little bit like adding and subtracting a variable, all right? The variables have to be same letter to same exponent, and so I mean, if it doesn't work, it doesn't work. So I mean, if I can put together 4x and 2x and I get 6x. I cannot put together 4x and 2y. I don't get 6xy there. That doesn't work. It has to be same number, same variable raised to same power. So when I do this for square roots, it has to be same square root underneath the number. So see how it's square root of 3, square root of 3? I can put those together. That's like saying I have 7 square roots of 3. Here, 2 square root of 2, negative 6 square root of 2. I can put that together. That's going to be negative 4 square root of 2. I can't do anything with the square root of 5, so I just add it on to the end. This would be simplified. So likewise, it doesn't matter if it's a variable. Here, on the left-hand side, I've got 5 square root of x, and I've got minus 3 square root of x. I'm going to put those together for 2 square root of x plus square root of 2. Now here's where things can get a little tricky. Right now on the surface, it doesn't look like these two are, like I can't put them together. Okay, they're two different things. However, square root of 27 is not simplified. I can split square root of 27 into square root of 9 times square root of 3. So that's going to be 3 square root of 3. Hey, now that this is simplified, this matches up. So it's like saying 4 square root of 3 minus 3 square root of 3. So that's like saying my answer is going to be 1 square root of 3 or just square root of 3. So I've got to simplify this first. All right, so if I look at some of these, they can get a little tricky, but you can still do them. So square root of 12, that's going to be square root of 4 times 3. So square root of 4 is 2, so I'm going to have 2 times square root of 3. So that gives me 4 square root of 3. 3 square root of 27, I'll change up colors here. That's going to be 3 times square root of 9 times square root of 3. This is going to be 3. 3 times 3 is going to be 9 square root of 3. The last one, 2 square root of 48, well, that's going to be 2 times square root of 16 times square root of 3. And did you notice how I ended up with square root of 3 on the first two, and it was pretty easy to pick off? If I get that situation, I'm going to be looking for a square root of 3 on my last one. So that's going to be 2. So I'm going to be looking to see how can I get a square root of 3 so I can put everything together. It's not always going to work, but a lot of times it does. So that's going to be 2 times 4 times square root of 3. So that's going to be plus 8 square root of 3. So 4 and 8 is 12 minus 9. Final answer, 3 square root of 3. Over here, you got square root of 8, square root of 32, square root of 18. Square root of 8 can be split up into square root of 4 times square root of 2. So that's going to be 6 square root of 2. 5 square root of 32 is going to be broken up into square root of 16 times square root of 2. So that's 5 times 4 times square root of 2. 18 can be split up into 9 and 2. So that's 9 times square root of 2. So that's going to be 4 times 3 times square root of 2. So that's going to be minus 12 square root of 2. So 6 plus 20 is 26 minus 12 square root of 2. So my answer should be 14 square root of 2. That was a tough one. All right, but if you break it down, take it piece by piece, you can put it together. All right, so find the perimeter of the rectangle. So here's what we got. Perimeter is, remember, start in a corner, walk around. How far did I go? So I'm going to have this, this, this again, and this again. So I'm going to have 3 plus 6 square root of 2 plus square root of 8 plus 3 plus 6 square root of 2 plus square root of 8. So now, if I start putting things together that already go together, I get this. 3 and 3 is 6. 6 square root of 2, 6 square root of 2 is 12 square root of 2. Square root of 8, square root of 8 is 2 square roots of 8. But now, square root of 8 is not simplified. As you guys are hopefully starting to notice, that one can be split apart into this. So what I really have is this. Plus 2 times 2 square root of 2. Notice how I replace square root of 8 with 2 square root of 2 there. A lot of kids that screw this up, we'll have 2 square root of 8, and then the next thing they'll write is 2 square root of 2. That is not the exact same thing. I need 2 times 2 square root of 2. So that becomes 4 square root of 2. So my final answer becomes 6 plus 16 square root of 2. There's my answer. So you and your friend are working on a sailboat. The distance in miles you can see to the horizon can be measured by the equation D equals square root of 3h over 2, where h is your eye level height in feet above the water. Your eye level height is 32 feet, and your friend's eye level height is 18 feet. Write an expression that shows how much farther you can see than your friend. So you are 32 feet in the air. Your friend is 18 feet in the air. Maybe you're up in the crow's nest and he's down on the deck. So you end up with square root of 96 over 2. Over here he ends up with square root of 54 divided by 2. So 96 divided by 2 is going to be square root of 48. 54 divided by 2 is going to be square root of 27. So this becomes, remember, split this up into 16 and 3, so 4 square root of 3. So he is going to be broken up into 9 square root of 3, so that's 3 square root of 3. So simplifying the expression is that you're going to see one more square root of 3 farther than he is, which, multiply together, calculate, and get an actual number. So pole vaulter's approach velocity v in feet per second and height reached h is related by the following equation. V equals 8 square root of h. Suppose you're a pole vaulter and reach a height of 20 feet on your opponent, and your opponent reaches a height of 16 feet. Compare those two basically. So your velocity, u hit 20 feet. Your opponent hit 16 feet, sorry. Compare these two guys. So 20 can be broken up into square root of 4 times square root of 5. So that's going to be 16 square root of 5. All right. If I want to do an actual calculation, that's fine. I can do that. So just throw it into a calculator. Don't get cute or fancy. Just go 16 times square root of 5, and you get 35.7771. Over here, what he's going to do is this. Square root of 16 is just 8 times 4, so that's going to be 32. So you got more velocity than he did, and on some level, I hope that makes sense. Okay, that's all I got. Take your, make sure you do the notes, you do the assignment, and then come back and talk to me, check your answers, make sure you know what you're doing. Thank you very much for playing. We will talk to you soon.